for coming. Thank Chris for inviting me to present here. Thank Mesosphere for hosting us, and thank all of you for missing some boring basketball game that's going on right now. So, I'm going to talk a little bit about TensorFlow.JS. This is a new thing that Google announced at the TensorFlow Dev Summit last month. It's one of their big announcements of the whole thing, and so Chris asked me to come in and talk about it. So here I am. So basically, originally I started to write I downloaded the stuff, I started writing demos, I started trying to write some cool JavaScript code or whatever, and decided actually that my goal really wasn't actually to write the coolest new machine learning recognition algorithm in JavaScript or whatever, but more broadly the question is, why would you use JavaScript to do quote unquote serious stuff like machine learning? This little comic strip is sort of one of the criticisms many people have of JavaScript, which is that it has sort of this ADD personality. So whatever you learn generally in a few months, that's obsolete, and everybody's moved on to the new frameworks package, et cetera, et cetera, et cetera. And so you're building a castle on top of sand, so to speak. So very broadly, I'm going to try and make an argument for why JavaScript is the most powerful and important programming language for you to learn today. Then we'll do a real quick jump through the MNSIT demo with the TensorFlow Layers API, which was added last month. We'll look at how you can retrain a model using Keras, export it to make a JavaScript model that you can then run. Then we'll look at how you would want to run the model against the video input stream in a browser, like a webcam, so to speak. And then we'll sort of discuss the next steps where you might want to go from there. Whenever we say edge computing, I think a lot of people have different ideas on where that is. So this loosely is how I would define it. You can think of just your computer or some sort of universal Turing machine or just raw math, right? The nuts and bolts of all this machine learning and stuff. But generally in the real world, we need some sort of dedicated hardware that interacts with our math so that we're doing things in an accelerated function. So the next level up from that, I would say that it's just basic virtual machines, like what you might encounter if you go through the Coursera machine learning courses. Paperspace does the same sort of thing where you get the one-click installer and you can go to the Jupyter web environment to do stuff from there. Next level up then, I would say is something like cloud software. So either the Amazon cloud or Google Cloud Platform. You might have multiple computers working together and you're trying to synchronize their work in order to produce a larger result. The next level up then would be what's called sort of the edge. We can think of this as being mobile devices, doing stuff with models in order to get them to run on your phone. But more broadly, you can really think of it as just being any embedded environment. Your laptop is really an embedded device. I mean, you can put this in the front of your car, plug in the cameras somehow, and in theory, if all your algorithms were optimized perfectly, you can run it just on this device, right? So really, any embedded thing is in some form of the edge. And then the next level above that, I would say, is where you get into the more exotic stuff, which would be custom hardware architectures like the TPU, local processor, or making your own custom ASICs to perform neural network calculations using hardware in the field. This is kind of what a lot of big people are super interested in right now. So, yeah, who here does machine learning in any form whatsoever? Yeah, let's see. Who here does it in JavaScript? Probably not a lot of you. So probably most of you use these other programming languages, be they Python or R, or maybe some Java. I've not seen a lot of people doing Haskell, but they're out there. I like this little Akiva guy for the JavaScript one for reasons we'll get into here in a second. So the question is, if you're not coding JavaScript, or rather, who here codes JavaScript, right? Ever has coded JavaScript at any point in time whatsoever? Yeah, I'm with it. Okay, so so here codes C++. One person, two people, three. Anybody here code Lua? One person, half a person. Yeah, you know. So if you're actually writing TensorFlow or like Torch, the native code for these platforms is written in C++ or Lua. It's not even regular C++. It's like Google's custom fork of C++ running Google's custom like C++ magic libraries, and so you have to understand how all this stuff works. And as a general rule, nobody wants to do that. Everybody just wants, give me a button I can smash to get the answer. And so what we have is these Python wrappers. For TensorFlow, literally the first thing that was developed was Keras, right? Everybody said, no, I don't want to run TensorFlow. I want to run little Python things to handle all my, my C imports. Torch, they started the PyTorch project, which is basically just, them admitting that there's not a large enough critical mass of Lua programmers out there to like convince everybody to no matter how beautiful the language is, there's just not that installed base. And so then the question I have for you is, who here actually codes in Python? Yes. Okay, how many of you think you code in Python, but you actually code in Jupyter, and then Jupyter sends your Python code off to a server, the magic happens there and it comes back. So you're not actually like, on a certain level, if you think about the Jupyter framework or whatever as being like a little JavaScript front end, but technically you're sort of writing like Python code into a JavaScript API, which is shipping it off to be executed, and then it's all coming back. So technically, you're already a JavaScript machine learning programmer today. You just don't think about it that way. So, why do we use Python? Python has historically been an excellent wrapper language. It's easy to pick up. They've always had a very good community, and they've always been really big about open source. I would argue that Python is kind of edged out. I don't know if you guys remember back in the 2000s or late 90s when Perl was the hotness or whatever. And then Larry Wall went off and did his old Perl 6 thing, and like the community fell apart, right? The same thing actually happened with Lua between the 5 and the 5.1 and the 5.2 thing, right? So they're like, and it's just a whole bunch of R. I know statistics people love R, but I don't think it's going to, it's going to be the thing that brings, allows everybody in the world to start programming machine learning stuff. But all these groups of people can all agree that they're way, way better than JavaScript, right? And the reason that you would use Python is just like what the Keras website is that it gives you this easy experimentation. And if you can experiment easily, you can try lots of things, and trying lots of things is what usually gets you to that one thing that actually works, at which point you go backwards and productionize it, clean up your code, et cetera, et cetera, et cetera, et cetera. So I would argue, though, that these are actually sort of weaknesses, because basically anything you can do in Python can also be done in JavaScript. JavaScript is, I would argue, a half-baked copy of Lisp, which has been reinvented every year for the last 50 years. Who here thinks themselves as a functional programmer? Okay. Who here would agree that anything you can do in procedural programming, you can do in functional programming? Okay. Who here would agree that anything you can do in functional programming, you can do in procedural programming? Right. So but so basically, I would argue that anything, JavaScript is like it can bridge to any world and it can like steal bits from those worlds. I was going to write well here, let's just stay here. I don't know if you guys are familiar with the MNSIT data set. This is one of the data sets I usually do for demos, but I don't want to do like a whole complicated breakdown of it, but pictures in, things out. The second part of the demo is that you don't actually have to even learn JavaScript. Any model you can do in Keras, 4 lines of code, you can export from Keras to JavaScript, which means that if you've got in Keras, you're like literally 10 seconds away from having a JavaScript version of your model. And then, we'll look at how you actually run the browser. The thing is that, like, if you look at the TensorFlow JavaScript examples that Google has given us, basically these 3 things are all in here already. I mean, if you've written much Keras code, then here's your basic MNSIT demo, which takes a model, builds some layers, runs things through a couple of convolutions, does a max pull, and then kicks the answer out at the end. There's your generic atom optimizer, FSGD. If you've done machine learning, the syntax might be a little weird, but this is all basically stuff that if you squint your eyes at it, it's just Keras code in a slightly different way of looking at it. So then they have like a whole, they'll pull down a MobileNets model. I don't know, sorry, MobileNets is like a fairly advanced image recognition network that is small. It runs in, we'll say, 10 to 15 megabytes worth of data, and then it's fairly computationally efficient because it uses just in how it's structured. It was an improvement upon the inception for doing mobile stuff and things like that. Basically, then if you go to the Google website, so here's your all the Javas. I mean, this is all the Python you need to know in order to take a model out of the Keras world and into the TensorFlow.JS. I mean, if you made this far, this is 8 lines of code, so presumably you can do that. And then, if you look at their actual webcam demo, it's all written in JavaScript wrappers, but we can take the webcam, capture a frame, send it off to our model, get our prediction step, and do it all just there in device. I mean, I can show you how to do all this, say, on like a mobile phone, and it'd be a lot of work. This is all JavaScript. It's nowhere near as elegant. It's ugly, et cetera, but it's all there. It's the same concepts, the same math, the same rules, everything else. So, so hopefully I've sort of convinced you that there's actually nothing to learn here with TensorFlow.js. The API itself is literally just, they took all the good parts out of Keras and they rewrote them into JavaScript. And they're going to add more stuff in the future, so it's that. So the obligatory XKCD comment. Okay. So then yeah, we'll go back around to JavaScript some more. So the argument then is there's an old essay about Unix and whatnot, and the argument is that worse is better. That Unix did a lot of things in a haphazard manner, but the tools they built and how they used them were fundamentally just they got things done and let people go on to the next thing, and that is that. So I will agree with you probably 100% that JavaScript is a terrible language with terrible syntax and terrible inconsistencies. I will go further, and I will say that JavaScript has the most terrible code written in it in the world. But the reason for this, and so everybody is allowed to look down on JavaScript programs. But I think the flip side, if you think about it, is that literally JavaScript is the most widely used programming language in the world, right? So by definition, it has the most bad programmers in it, It's everybody's first programming language, so it's the language with the most, oh, let's see if this works, gets written. I mean, literally, that's what, And so if you take out that whole thing of it being, having the most terrible code in existence and flip it around, that's another way of saying it's the most widely used language in the world today. It has the largest number of developers, and ultimately, long term, it has the largest number of devices that can, run all this stuff. So, the second part of my argument is that no other language evolves at the speed of JavaScript. I think every 3 months or so, there's like a new generation of APIs, tools, frameworks, etc. The value of each generation, I would argue, is a random integer that's not in any normal distribution. Literally, sometimes they go backwards. It very stochastic, so to speak. But what's going on in JavaScript today? By September there'll be a new thing. By the end of the year there'll probably be a new thing on top of that. And it's just the nature of that stuff that literally everything JavaScript just steals from everybody else, and people steal a few things back, but it's ultimately just mostly a one-way street. Apple is the one that people love. I would argue that Apple does big, beautiful releases, but they only do one release a year, right? And so maybe they're 2 years ahead, maybe they're 3 years ahead. Maybe it'll take 10 generations of little bit JavaScript changes in order for them to catch up, but it's only going to be 2 years, 3 years, And so, the future is much more closer to like a web programming world than it is to this world where we sit around and we write, beautiful code and beautiful offices, so to speak. And so then the question is, where are we going with all this? I believe that machine learning or AI or more broadly computer science in general is basically the modern form of literacy. And back whenever reading and writing was invented, if you could read, you could literally get a job, right? And today, if you can code, you can get a job. People don't even really care if you have a good personality or you have to do all this other stuff that will get you washed out of a lot of industries, to be honest. But as long as you can make the little keyboard dance, they'll let you in the door. And so then the question is, if we imagine the machine learning temple or the AI temple, of academia, or do we wait for all those people to, all these just random JavaScript programmers, all these random new programmers in the world to try and come and follow the proper path, or do we go out and we try to, help them, reach this glorious future or whatever? And so, basically my argument is that the barbarians are the gate, and it's time to tear down the ivory towers, and where can you make these tools and whatever way you do it or whatever, it's just literally, you're helping increase the size and scope of machine learning and literally making the world a little bit better, a very tiny amount, but one step at a time. Yeah. And then, just a little outro of some stuff that you should look at. TensorBoard, which is part of the Google tools, is the JavaScript's using there. The cool thing about this means is that then there's a team of machine learning PhDs at Google who are maintaining all this JavaScript code. So just give them enough time and all the bugs will hopefully be fixed, knock on wood, right? I forget what the TensorFlow scene. Ah, yes, the TensorFlow demo in the browser, how to do the CNN ones. I don't know if you guys have seen that one, but it's just a cool use of JavaScript in general. Yeah. Oh, well, if you look, they have a nice demo where you can pull sliders and stuff and learn how MNSIT actually works on a low level. Keras.js is like an older one. I thought this one was really cool just because they had some really cool demos where I think all this stuff's going to go eventually. They're like doing little bitty GANs in TensorFlow, right? Here's the standard bunch of different models, doing LSTM in JavaScript. I mean, there's no reason that you can't port any of these other techniques over, right? It's just, and yeah, I think ultimately in the future, people are going to get all these node modules stuff figured out, and then you'll be able to run your, you'll be typing stuff in your browser, and it'll just sort of, send things off to a GPU someplace else, get the answers back, and then it'll come back, but we'll just be doing it all locally. But that's about all I got. So, you guys want to talk more or questions? Or, I got no grand finale. Sorry, that was it right there. Sorry. Sure.
So I must say that I run as a Scala developer, and I'm very fond of Scala. I hate them languages. So, question. Everything type programmers hold dear, right? Consistency, compile time, safety. So normally we think that machine learning deals with data which are important, such as life and death, health, care, money. Do you really want to interrupt all this to a globe of JavaScript? So because when you pass things from browser to the server in this language, you're not ensure that anything is serialized, deserialized as you intend, so that you really got what you meant. You don't have any control, any checks, anything. So do you really want to do that, and why?
Do I want to do it myself?
Why? Surely Google can pay the machine pages enough to, they will do that. They will like spit and curse and do that. But why, philosophically, why would you want to do that? Surely then most masses, could do whatever they want. In the sense that obviously, if you bring a lot of people into something, the average will drop dramatically. Doesn't mean that we should do this as professionals, right? Like, should uphold the ideals of type programming and compile time security and safety, or should we do that?
I'll agree that that's how things should be, I guess, and et cetera, et cetera, et cetera. But like I said, I think the future is coming. I think, and if so yeah, if you're doing data science now and you take a project and you go off and take a month, someday you're going to be treated like a web programmer would be my broader argument, right? So you're going to have daily stand-ups and you're going to have to deliver.
But the industry will support this because the first time the data is lost and some major fuck-up ensues, the first time it's backfires, enterprise is going to say, why are we doing this? Yeah. Isn't it the banks are using Java, banks are not using JavaScript. So would you say that the history of the industry shows that it's not as easy to learn?
No, I would agree. I'm doing another talk tomorrow, I guess, on convolutional neural networks in general, basically, part of the argument I would make is that, if you're going to bet on something, I think this probably would be where you'd want to bet. Sure. So you're a functional programmer. Okay. So basically, ultimately, a lot of this production stuff is a question of optimization, we'll say. Multi-GPU programming sucks. I don't know if anybody here just tried that. And I think ultimately, in order to make to ultimately do the higher and higher level optimizations, you need to basically have a complete vision of the graph model that you're building. And if I was to bet, I think this is where a lot of the big people are going right now. Facebook has tensor comprehensions. They have the halide things, and basically people are writing DSLs. I would argue just for doing these hardware operations, and then you just need the complete graph model in order to make your correct DSL out of that whole thing. If I was a betting man, this is where I would bet,
I like this much, but
if you're asking me if the future is going to go towards what I think is the right path, or the slightly, ever so slightly cheaper or easier path, that's wrong. Then usually it almost always goes. I don't know. Any more questions or? I'm doing another talk tomorrow in San Jose at AltConf. We're going to go through a whole bunch of, I got 60 slides there, so a bunch of different stuff. But yeah, I normally do MNSIT. It's like a good way to walk people through the paces of machine learning. And Chris is back there. I don't know. I'm running out of material up here, Chris. I can talk about Donovan if you want, but.